All right, so July week 1, this is OSS. I will present these guys.
And there will be some barking.
There will be some barking. My coworkers are pretty energetic right now. Okay, so what I wanted to show is a couple more notebook features that I've implemented. So one of them is what we call soft save. So this file I've changed. I haven't actually saved it yet. The unsaved indicator is there, and if I refresh this tab, then it'll come back and it's still there. You'll also notice that it saved the layout. So if I open up another file and put that beside it, and then refresh or reopen, then it comes back with the same layout that you had before. I've also got a prompt now. If you try to save file with the same name as another file, it'll prompt you to ask if you want to overwrite it. We didn't have that before, so that protects you from doing something stupid. And you can also move files, drag and drop, just like that. There you go. And so those are some of the notebook changes that I've done this week. And that's it from me. So do we want to move on to Christian then?
Okay, so I have a few Parquet-related things to show. I'm going to be presenting now. So I'm going to first show some of the file data in a command line window. I don't want to switch windows many times, so I'm going to ask you to take a little bit of a look at some things in these files. If you are from DevRel, some of these things may not be very novel to you because we discussed them in a presentation that we had, but there is this tool called Parquet CLI. It's an open source tool, and it lets you take a look at a Parquet file and look at things like the schema. So I'm going to use that tool to look at one of the two files that I have there. Amanda, by the way, was the person who got these files for us, which was super helpful. So this is the schema for one particular file that is called taxi.parquet. Some interesting things here to note from the point of view of what we're going to see later are these two columns here have a timestamp in macros, which is something that Deephaven Enterprise did not support in the code that we inherited. The other thing to note here is that this S here, you're going to have to trust me. It means that the data is compressed in a compression codec that is called Snappy. It's a Google codec and it's a default Parquet codec. It's going to be interesting because I'm going to switch now to present the Deephaven window. You should be seeing the Deephaven ID now. And I'm going to start this Fetch ID. I'm going to import from Parquet tools. That's a change. It used to be table management tools. Now it's Parquet tools. And I'm going to read that table. So it loads, no big surprise there. But one thing that I can do now is that I can write that table with a different compression format that before we didn't support. So I'm going to be saying, please save this in gzip format. If I switch to the other window, you would see that I have a new file now. And if we look at the length of that file, it's actually smaller because gzip takes longer, but it actually is a better compression with less and the resulting data. The other file that we have there, it's called monthly product sales. It's an interesting file in the sense that it's a legacy Parquet file. It's a before 2.0 version of the format. And that has some interesting properties from the point of view of the information that you can get from the schema. In particular, you cannot tell if a binary column is a string or not. You have to know and to be able to load that you essentially get a binary array, and we're going to see that here. We have here month of order date, product name, and sales, just 3 columns. And you see numbers here in an array because the strings are not showing. Another thing that is happening here that is also part of the new features is that you see the underscore there in product name and month of order date. These columns have spaces on their names, which Parquet supports, but Deephaven does not support. So we're doing an automatic conversion there to using an underscore. And as a user, you can also specify if you want something different than the default for how to handle that. If you want a dash, for instance, you can do that. So what I want to do now is I'm just doing a view so that you can see that those are actually strings, and these are the actual values. So yeah, that's it. That's my demo.
All right, very cool. I think next we had Alex.
Yeah. Okay, I'm going to present my screen. Let's see. I've not used Google Meets to present before. How about this? Can y'all see the IDE?
Yep.
Maybe.
Yeah.
Okay. Cool. So there are a couple things here. I think the first is that who this thing is for that I've been working on, and then what it does. Just really briefly, who it's for. It's not for people who have never seen PyTorch code or TensorFlow code. These are common deep learning libraries that data scientists use. We are not trying to hide any of that complexity for our users. This is aimed at users who would, maybe consider themselves data scientists and who are familiar with these frameworks as it is. So the idea here is to sort of provide a unified interface for going between Deephaven tables and using PyTorch or TensorFlow or scikit-learn or whatever it is that you'd like, using their deep learning capabilities on Deephaven objects. So at the moment we can't do that, but so I've been working on this thing that kind of facilitates that. And so I've got a bunch of code up here that will come in a Deephaven library. Got a data set. This is the Iris data set. It's a default data set of ours. And a lot of this is just boilerplate PyTorch code for defining models and making things happen. If you want to program in PyTorch, you have to do this anyway. So with all of these things, Deephaven is not adding any complexity. So I'm just going to run all this so that I can use it. Let's see. And then there are a couple of these kinds of functions that kind of tell the data how to coalesce into objects that PyTorch wants to see. These can be user defined. We might provide them ourselves. And then we have this function down here that's kind of the thing that wraps everything together and makes it all happen. And so this will basically create a new table, perform some classification on that table, train a neural network, and there you go. You get your column of predicted values, say. And importantly, if you're using default functions, the only code that's been added on the Deephaven side of things are these 3 lines of code. Nothing else really differs from what you need to do to get PyTorch working in any other IDE. So this is cool, but what's cooler is that Deephaven is really good at real-time stuff, and none of these frameworks can touch that at all, as they are. So what I did today, I have this sort of fake Iris data set. It's a data set that I'm going to generate that has the same distributional properties as the Iris data set, but it's ticking in real time. And so the idea is, these frameworks are great for deep learning and doing classification and prediction and things like that. And I would like to be able to do that on real-time data. And what's really cool, we actually don't need these functions. I already defined them. But I'm going to go ahead and run these. Let's see. These are just functions that, again, the user would define to tell them how to make predictions on the data. again, it's all stuff that you have to do outside of Deephaven anyway. And you use the exact same kind of function call in the exact same way to produce essentially a classification on a live data set. Oh, wait, I was about to do something silly. Because things don't quite work as they should, I have to go out here and uncomment this and uncomment that. Will not have to do that in the final thing. That's what I have to do right now. When that's done, you can just execute this same function call that again, the interface is not, it does not change between static data and live data. And it doesn't care whether you're dealing with PyTorch or TensorFlow, it feels the same. And I don't yet have it to where it actually populates the table with these classifications. But what you can see is that every time the table ticks, I get a new classification up here. So as soon as I called it, it classified all of these new observations using the model that I already trained. And at each tick of the table, I get a new classification. So this can be used for real-time time series predictions. This can be used for real-time classification. It's obviously not complete. I have to figure out how to get things into the table. And Colin and I talked about that for a good long while, not too long ago. But yeah, so that's what this does. It really serves to, I guess, extend the functionality of these pre-existing deep learning frameworks into the real-time space. And it makes it to where Deephaven users don't really have to care whether their data is live or ticking. The interface is the same. They can use TensorFlow, PyTorch, scikit-learn, pandas, whatever you like, and the interface is the same. So it's really just making that process that much easier for our users, and hopefully encouraging them to do cool stuff like real-time classification. So here you go. That's what I got.
I mean, it seems very exciting to the extent that these communities have begun to coalesce around Arrow and Arrow Flight. And, you know, they're obviously using Python, they're using these libraries to the extent that we can feel like an upgrade to all that, it's pretty natural for them to use. You know, particularly it's like, oh, they're using all this stuff, and sometime in a couple months we deliver the Jupyter Notebook experience as well. It should feel like, well, they get to use all their familiar things, but they have enhancements that probably they didn't expect to be arriving anytime soon. So very exciting and nicely done, Alex. Do other people have questions?
Cool.
JJ?
Yeah, thank you.
Yeah, JJ next, and then Colin after.
All right, so apologize if I have any service interruptions. It's been a little finicky today, but let me share my screen. So my demonstration is not as exciting as Alex's. You guys can all see my screen, right?
Yep.
Okay. So what I'm demoing today is just an introductory use of DynamicTableWriter to write real-time data to a table. This was actually, if you saw how Alex was doing it, he was doing it with DynamicTableWriter. So what this code does is it uses a Python module, or it installs it. It's called CryptoCompare, which can pull live crypto prices into a table. And then every 5 seconds for 50 seconds, it will write 3 coin prices. Those are Bitcoin, Dogecoin, and Ethereum to a table, along with date and time strings. So if we run this code block here, you'll see on the right, there'll be a table called crypto prices that will update every 5 seconds. Basically, if you import JPy from Deephaven, you can fetch the DynamicTableWriter object from JPy. You can define the TableWriter object with each column and what data type will be in the column. You can designate what the name of the table is that it'll write to, define a function, and then run the function in a thread. And that's how you can start getting some real data into tables from external sources pretty easily. And that's pretty much it. So, like I said, nothing too exciting, but honestly, it's pretty easy to use this, which is nice.
Yeah, and once we get that wired up with some plotting too, that'll look really cool.
Yeah, yeah. There right now there's no convenience types for setting the data types of each column. So if you see here, I don't want to move this, please. If you see here, I actually have to manually set the data types using jpy.getType in there, as opposed to explicitly casting it to a Java lang string or a double or anything, which is a little cumbersome. But I think I made an issue in the created an issue in the Deephaven core repo about that. So
Cool. All right. Any other questions for JJ?
I did forget to mention that when I did the data generation, I totally used everything that JJ just showed y'all. I did not come up with that. That was all
that's all right. It's all very simple stuff. So, which is actually really, really a good thing. That particular little code block is what I'm using in a how-to document because it's really simple and just shows, hey, here's a really easy way to get data into a live ticking table.
Yeah, as a user, it was really easy, and I could not have done that without the work that you did. So, just mention that.
All right. Cool. Okay, Colin.
Pete was speaking about Arrow a little bit ago as one other way we can interop with other platforms, other data platforms that people expect to be able to work with. Arrow, whether it's Java or C++ or Python, have the ability to send data back and forth using a package called Flight. And Flight is the basis of Barrage, the way we're sending ticking data. But we can still speak plain vanilla Flight. So this Flight client is part of the Java package that they provide for us. I have the server already running. I have a simple client here that uses the ArrowFlight client and basically says, get stream. Now, get stream actually doesn't mean get a stream of data. It just means open a stream and get data until you've seen all of what the table has to offer right at this moment. Once you've grabbed that, you get one single shot at reading the table. This is how it ends up storing the data. And if I ask it to print it to a tab-separated file, we get, in what is a ticking table, printed out to the screen pretty simply. So this is an interop format that's expected to work by anybody who's using Arrow, whether it's Java, whether it's Python. It also works to get data into the platform. So instead of new table, it will now be a do put method using Arrow's do put format. And that'll be a way of saying, hey, I've already got this data in memory. Please ingest it and start doing some of the automated stuff that Alex, for example, was demonstrating.
All right, cool. Any questions for Colin? All right, wicked. I think that's it. I don't think we had anybody else to show, so signing off for the demo video.